Right, so we're going to work through the solutions to the second revision paper that I've put together for the Unit 1 maths paper, which is the paper that the calculator is not allowed in. And these are the even number questions based on similar questions to those that came up in the November 2016 paper. Majority of the topics that are in here can be practiced if you go to jonesthesum.co.uk and go to the topics page there. You'll find lots of similar practice questions. And as I've done with the other ones, just to give you some idea of the level of difficulty of the questions, the first group of questions up to and including question 8 are the sort of questions that overlaps with the foundation tier, so those would be DE grade questions. Question 10 and question 12 you could say are of grade C difficulty, and 14 and 16 are of grade B difficulty. So in order to be confident of getting a C, you need to be making sure that you are comfortable at being successful in those first 6 questions up to question 12. Okay, so let's get cracking. So the first group of questions are true-false questions, and what you have to do here is look at the statements and then decide whether or not they're true or false. Now it's really important that you don't just guess these, in particular if they're in the first half of the paper. So there's space for working and you should use that. So the first statement, 20% off £120 is the same as 80% of £120. Well, it's a non-calculator paper, so let's get cracking with our 10%. 10% of 120 is divided by 10, 120 divided by 10, £12. So 20% is going to be twice as much, £24. So 20% off 120 means that you're reducing £120 by £24. So that'll be 120 less 24 equals not 6, 96. So 20% off leaves you with £96. 80% of, well, if 10% is £12, 80% of 120 will be 8 lots of 12, which is also £96. So 20% off and 80% of are the same, so that is true. A half of 60 is the same as 15 divided by a half. Well, a half of 60 is 30. And you will probably have been taught that when you divide by a fraction, what you end up doing is inverting that fraction, the one that you're dividing by, so turning it upside down, and the divide becomes a multiply. So that's the same as 15 times 2 over 1. Well, 15 times 2 is 30, over 1 is 30. So a half of 60 is the same as 15 divided by a half. So that's also true. 2 cubed is the same as 3 squared. Well, 2 cubed, you need to know when you're cubing, you're not multiplying by 3, you're multiplying by the number by itself 3 times. So 2 times 2 is 4, 4 times 2 is 8. 3 squared is 3 times 3, which is 9. So 2 cubed is not the same as 3 squared, so that is false. 3 cubed is not the same as negative 3 cubed. Well, 3 cubed, same thing again. 3 times 3 times 3. 3 threes are 9, 9 threes are 27. You should really know what 2 cubed is, what 3 cubed is, and ideally what 4 cubed is, because you may be asked a question where you have to find the cube root, which is going the opposite way. So the cubed root of 27 is 3. Negative 3 cubed means negative 3 times negative 3 times negative 3. Well, negative 3 times negative 3, 3 threes are 9. The sign's the same, it makes it positive 9. Then you're doing positive 9 times negative 3. 9 threes are 27. Signs are different, answer is negative. So 3 cubed is 27, negative 3 cubed is negative 27. So 3 cubed is not the same as negative 3 cubed. Well, that's true, they aren't the same. And dividing a number by 100 is the same as multiplying by 0.1. Well, dividing by 100, let's pick a number, say 500 divided by 100 is 5. 500 times 0.1 is going to be 50. So they aren't the same. You'd have to be multiplied by 0.01 for that to be true. So that is false as well. Now the marks for that, you're going to get 3 marks if you get 4 or 5 correct. You're going to get 2 marks if you get 3 correct. And 1 mark for 2 correct. If you don't get 2 correct, you don't get any marks. Okay, next question. Write down the next 2 numbers in the following sequence. So this is in the first half of the paper, so it isn't going to be one where they're looking for an nth term rule. They just want you to continue that sequence. So you can see it's going down. The first pair are dropping 5, the next pair are dropping 5, so the sequence is that you're subtracting 5 from the previous number. So 4 subtract 5 takes you to negative 1, and negative 1 go down another 5 on the number line and you end up at negative 6. So the 2 numbers they're looking for are negative 1 and negative 6, and you get 1 mark for each of those. Simplify the expression 9r, take 3s, add 2r, take 3s. So when you are doing this, you need to be gathering up the terms that are the same. Now, if the first term has got no sign in front of it, it means it's positive. So each term has got 3 parts: a sign, a number, and a letter. So that one and that one are the same. So I got plus 9r and I'm adding 2r. That's going to take me to 11r. And then here I've got a negative 3s and another one. Now this isn't minus minus makes a plus because I'm not multiplying them and the signs aren't together. What this is saying is I'm at negative 3 on my number line and I'm taking off another 3. So I'm going down the number line another 3, which takes me to negative 6s. And you get 1 mark for each part of that you get correct. Using the formula 3e equals 2f plus g, find the value of f when e is 8 and g is 6. Now, a really common mistake here is to then write 3e as 38. You must remember in algebra that the number and the letter are joined by multiplication. We just don't write it because then we get confused with an x. So in algebra we don't write the multiply, but as soon as we get rid of the algebra and we're into arithmetic, the times the multiply comes back in. So 3e is 3 times 8. 2f, we don't know f, so we keep that as it is, and g is 6. Well, 3 8s are 24. And what that gives us then is an equation with one unknown, f. Now, more often than not, you will be familiar with that written the other way around, where the f and the 6 are on the other side and the number on its own is on the right hand side. The rules are exactly the same. So to get the 2f on its own, we have to get rid of the add 6. To get rid of add 6, we have to do the opposite of adding 6, which is subtracting 6. So 24 take away 6 is 2f. 24 take away 6 is 18. So 18 is 2f. So in order to work out what f is, we have to half it. The opposite of timesing by 2 is dividing by 2. So f is 9. And mark-wise, you will get 1 mark if you correctly substitute in and get the evaluation. So getting down to that point will give you your method mark, and then to get both marks you need to get down to f equals 9. Okay, question 6. So this is the one where you've got an extra 2 marks for communicating and organising your work. That is not 2 marks for writing an essay. A lot of the work that I've seen over the last month or so, when you see the OCW mark, you think you want to write a story, and it's not that at all. It's concisely explaining step by step what you're doing. So let's read what we need to do. So the area of a rectangle is 30 square centimeters. Its length and width are whole numbers. Find the smallest possible perimeter of this rectangle. You must show you're working. So you need to know how to find the area of a rectangle. Hopefully, if you're in the intermediate tier, that is something that is pretty straightforward for you. So, length, width. So to find the area, it's length times width. So let's communicate that. And in this case, the length and width are whole numbers. So let's put it in a table. So I'm looking for 2 numbers that multiply together to give 30. That means what I'm actually looking for are the factor pairs of 30. What numbers divide into 30 exactly? And let's be organised about it. Let's say the first one will be 30 times 1. 30 times 1 is 30, area of 30, and the perimeter will be 30 plus 30, (62). What would be the next 2 numbers we'd put there to multiply to give 30? Well, 2 and 15 will give me an area of 30. What will the perimeter of 2 and 15 give me? 34. Smaller. What will come next? Well, a width of 3 and a length of 10 will give me an area of 30. So 10 10, 3, 3. Perimeter of that would be 26. If I choose a width of 4, then I'm going to have a decimal there. It's not going to give me a whole number, so I don't have to worry about that. So the next one will be 5. 5 into 30 goes 6 times. 5 6s are 30. What's the perimeter of that one going to be? 6 and 5 and 6 and 5. 12, 22. So that perimeter is much smaller than the first one. Now after that, the only thing that will happen is that the width will become 6, and if the width is 6, the length is 5. So all that happens then is that the rectangle changes shape, but it's basically the same thing. So we don't have to go any further. It's just turning around. So the smallest possible perimeter is 22 centimeters. Now I've written the story. In fact, I've used very few words at all, but everything that I need to know to answer that question is laid out there. You didn't have to put in the table, but you needed to show that you were organised and systematic in your method. So the marks for that question, you got 1 mark for coming up with a pair of numbers with an area of 30. So any pair, area 30. You got 1 mark if you then worked out the perimeter. So any one of those where you've got a length and width with an area of 30 and you've worked out the perimeter, you're getting 2 out of 4. You get the 3rd mark if you get to the 6 and 5. And 1 mark for the smallest perimeter. And then your organisation and communication mark, the 2 marks there, are for a systematic approach and clear explanation. So there's 6 good marks there that you can earn without writing an essay. Okay, question 8. State whether the following statements are true or false. You must give a reason for each of your answers. Now you won't earn any marks for saying true or false if you don't give a reason. But if you find yourself giving good reasons and forgetting to say true or false, then you will pick up the credit. All prime numbers have more than 2 factors. True or false? Well, hopefully you will know the standard definition that your teachers would have given you for a prime number is a prime number only has 2 factors. Only 2 numbers go into any prime number, which are itself and 1. So that is false. Because, so this is the important thing, you're not just saying it's false, you're giving a reason. Pick a prime number, 7. 1 and 7. So that's only 2 factors. All square numbers have an odd number of factors. Well, you may not be sure about this, so what you then do is say, well, let's try some. So, pick a square number, 4. How many factors has 4 got? 4 has got 1 times 4 and 2 times 2. 1, 2, 3 factors. Let's try 16. 1 and 16. 2 and 8. 3 doesn't go into it. 4 and 4, and nothing else does. 1, 2, 3, 4, 5 factors. But 1, which is a square number, still only has 1 factor, which is 1. So you can see here that because when you're working with factor pairs, a square number has 1 factor pair where it's multiplied by itself, it's always going to be an odd number. So it's true because for square numbers, 1 factor pair will be multiplying by itself. So you've got to come up with the fact it's true. You can give some examples. If you give an explanation like that as well, then you're well away. So there are 2 marks for each of those. Explanation marks, that's where they've got E's next to them. And really they are 0 or 1, 0 or 2. You need to be able to say it's false and give a reason, it's true and give a convincing reason as well. Question 10. A regular polygon has 6 sides. What is the side of its exterior angle? Well, a 6-sided polygon is called a hexagon. Question could have said that. And you need to learn and remember that to find an exterior angle, the exterior angle is the one that's outside. So if you imagine that you start walking from that point, you reach that direction, you're looking that way. You then turn through that angle and then start walking. You're looking in that direction, you turn that way. You reach that point, turn that way, that point, turn that way, that point, turn that way, and you're back to the start. So if you've gone around a complete turn, you've gone around 360 degrees, and it's taken you 1, 2, 3, 4, 5, 6 sub-turns to do that. So to calculate that exterior angle, you do 360 divided by the number of sides, because that equals the number of turns. So in this case it's 6. Hopefully you can see 6 goes into 36. 6 times, so it's 60 degrees. If the question had asked you what the interior angle was, well, these are the interior angles, and they lie on a straight line with the exterior angle. So if the question had said what was the interior angle, you'd have done that first of all to find the exterior, and then taken that away from 180, so the interior angle in this case would have been 120. So there's a method mark there, which is for writing down 360 divided by 6, and 1 mark for getting 60. Part B. In answering this question, you must show all your construction arcs. Use a ruler and a pair of compasses to construct an angle of 45 degrees at the midpoint of the straight line below. Label your angle 45. Okay, so you're going to need one of those. And to find the midpoint of a line, you need to construct what we call a perpendicular bisector, and these are techniques you need to learn. So if that means nothing to you, then you need to go and practice that. And again, if you go onto the Jonathan Sums website and look at constructions, then you'll get plenty of practice. So to find the midpoint of that line, you take your compass, you open your compass so that it's visibly over halfway. It doesn't have to be exact, as long as it's visibly over halfway. That is. Put your compass point on one corner and draw an arc above the line and below the line. Now on the actual exam paper, you'll have gaps, you'll have plenty of space either side. I've stuck an extra question in there just to save some space when photocopying. But the examiner will need to see all these curves. You then move your compass and you put the point on the other end of the line, and you make sure that your two curves cross, as you can see there. So they're crossing there and they're crossing there. When you join those up, not only does that cut the line exactly in half, but it also cuts it exactly at 90 degrees. So that's called a perpendicular bisector. Perpendicular means at right angles to, bisects means cuts in half. So if I know that's 90 degrees, I also know that 45 degrees is half of it. Another construction technique that you need to know is how to bisect an angle. So for this, there's my 90 degrees. My angle is going to be at the middle there. So what I'm going to try and draw here is that at the center of there. So that point is there. You take your compass and you put it at the center of where your angle is coming from. Open it out, doesn't matter how far, so long as once you've opened it, you keep it at that width. And you mark an arc on each side of the angle you want to cut in half. So there's a mark there and a mark there. You then move your compass without changing its size to the first arc you made, and you cast that into the middle of your angle. You then do the same thing from the line, the dash, the arc on the other side of the angle, and you cast that into the middle. What that does is cut that in half, and then you join where your angle is coming from through like that, and that is your 45 degrees. Now the examiner is looking for these. He has to be convinced you haven't measured 45 degrees. It's an intermediate tier paper. He's assuming you know how to use an angle measurer. So without these construction marks, you won't get the marks. So it's important that you put those in, and they're easy things to practice. If you're not sure about them, go and have a look on the topics constructions on the website. The marks for that, you get 1 mark for constructing the midpoint. You get 1 mark for constructing the bisector. And 1 mark for complete. So the question saying label your angle 45 degrees. So that should be a nice easy 3 marks for you. If it isn't, you need to practice. Okay, number 12. The spinner shown below and a fair coin are thrown together once. How many possible outcomes will there be? Okay, often it's easier to list them than guess them. So if that spinner landed on 1, the coin could land on a tail. But we could have a 1 and a head. If the spinner landed on a 2, we could have 2 and a tail. And we could have 2 and a head. 3 tail, 3 head. 4 tail, 4 head. 5 tail, 5 head. Those are all the possible outcomes from spinning that spinner and throwing the coin. Nothing else can happen. So how many possible outcomes will there be? 2, 4, 6, 8, 10. What will the probability be of getting the arrangement shown in the diagram? Well, the arrangement shown in the diagram is 4 and a tail. How many times can 4 and a tail come up? Once. When you're writing probability, write it as a fraction. The number on the bottom is the total number of possible outcomes. 10. What will the probability of getting an even number on the spinner and a head on the coin? Well, how many ways are there of getting an even number? 2 and a head. So 2 and a head is there. 4 and a head is there. Those are the only even numbers. So the chances of you getting an even number and a head would be 2, and again out of 10. Now you could cancel that down to 1 over 5. It's not asking you to, and don't do so unless you're confident you're going to get it right. Very often I see students who will incorrectly cancel that fraction down, or incorrectly write it as a decimal or a percentage, and then have to lose the marks. So if they're not telling you to give it in its simplest form, you're safer leaving it as it is. So for that one, 1 mark for each. Question 14. Arrange the following numbers in ascending order. Now, I'm going to bounce onto a bit of paper for a moment, because there's not enough space there. Hang on. Let me find some paper here. When you're working with standard form, think about place value. Think about what you were taught in primary school. You start with your decimal point. On this side of your decimal point, you've got units, tens, hundreds, thousands, 10,000s. And then you come to secondary school and we teach you about this side of the decimal point, where you've got tenths, hundredths, thousandths, and so on. Further on in secondary school, we teach you about index form, and the fact that this one, the units, would be 10 to the 0, 10 would be 10 to the 1, 100, 10 squared, makes sense, 10 tens are 100, 10 to the 3, 10 to the 4, the next one would be 10 to the 5, etc, etc. And this side of the decimal point, you would have 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, 10 to the negative 4, and so on. So 2100, if we want to put that on our place value scale, 2100 is going to be 0, 0, 1, 2. So the 2100. 2.4 times 10 to the negative 3, the 2 is part of that column. So we would have the 2, 4. Okay, so 2 is to the negative 3. The 4, we only have one decimal point, which is there. Sorry, I wanted to put this on the next row down. So we'd have 2, 4, and then we'd fill these in with zeros. So that number is much smaller than that number. Then we've got 2.4 times 10 to the 3. So the 2 is linked to the times 10 to the 3. And then 4, so that's our 2.4, and then we fill in the gaps with zeros. So that number is a lot bigger than that number, and is also bigger than that number. 10 to the 3, well, there's 10 to the 3, and we've got one of them. So that would be, it would look like that. So when you're working with standard form without a calculator, I think it's often helpful to lay your work out like that. On the back of your paper, it doesn't have to be somewhere where it's marked. Knock out your 100 tens and units grid, turn them into the powers of 10, and then write your numbers in. Obviously on a paper 2, you would like to use a calculator, and you're not going to need to do that. So going back to this question then, the smallest number is what we have to write first, which is this one. And we need to write it in the form it's given. So that's your 2.4 times 10 to the negative 3. The next smallest number is 1,000. What's 1,000? 10 to the 3. Then 2,100 is next, which is written as 2,100. And the biggest number is 2,400, which is 2.4 times 10 to the 3. Evaluate 6 times 10 to the 13 plus 9 times 10 to the 13. Well, they're to the same power, so we can just add them together to get 15 times 10 to the 13. Now that's not in standard form, because this number has to be between 1 and 10. So to put that into standard form, it's going to be 1.5, and that would mean moving one step further in this direction. So it would be 1.5, just like that. You could say that one there is 21 times 10 to the 2, but that would make it not standard form. So rather than 21 times 10 to the 2, we write it as 2.1 times 10 to the 3. So rather than 15 times 10 to the 13, we can have 1.5 times 10 to the 14. The standard form is on the website. Go and take a look. So the marks for this, you will get 2 marks for getting them all right, and 1 mark for 3 in the right order. And for this one, 1 mark if you end up with 15 times 10 to the 13, and 2 marks if you then simplify it. And the final question. At lunchtime, the probability that Kelly buys a bowl of soup is 0.7. The probability that Kelly buys a sandwich is independent of her buying a bowl of soup. Means it's whether or not she's got a bowl of soup makes no difference as to whether or not she's going to have a sandwich as well. The probability that Kelly buys a bowl of soup and a sandwich is 0.28. Complete the tree diagram. So when you, and again, if you've never done tree diagrams, there's no point in trying this question. You're better off going to practice some Again, go to the website before coming back to this, because this is an unusual question. So the way that a probability tree works is that if you were travelling along branches in the same direction, you were using the word and you are multiplying the probabilities. So if I'm going from there to there, I'm saying Kelly buys a bowl of soup and buys a sandwich. If you have to come back to the start, then you're using the word or, and that means you add the probabilities. So for example, if you said what's the chances of her not buying a sandwich, well, she could buy soup and buy a sandwich, same direction times, or, we're back at the start, does not buy a soup and buys a sandwich. So if you're going in that direction back to the start, or, you're adding. Now this is saying that buys a bowl of soup and a sandwich, that means buys a bowl of soup and a sandwich, this outcome is 0.28. So what we need to know is 0.7 times what is 0.28, and hopefully you can see that 7 goes into 28 4 times, so it is 0.4. Now once you've done that, to work out these other branches, these two branches must add up to 1. Kelly's either going to buy a bowl of soup or she's not going to buy a bowl of soup. Total probability is 1, so if that's 0.7, that's 0.3. Similarly, if that's 0.4, she's either going to buy a sandwich or she's not, so that must be 0.6. Buy a sandwich, 0.4, don't buy a sandwich, 0.6. So that's how you complete the tree diagram. Now usually, the vast majority of probability tree questions, you've got to work out the value that they've actually given here. So you've got to fill this bit in and then work that out. What's unusual with this question, and the one that was on the November 16 paper, is that they actually gave you one of these and you had to use it to find the probability on one of the branches. So finally, find the probability that Kelly does not buy soup and does not buy sandwich. Does not buy soup and, travelling along here, does not buy sandwich. So you're going to do 0.3 multiplied by 0.6. 3 6s are 18. 2 digits after the decimal point means there'll be 2 digits after the decimal point in your answer. So 0.18 is what they want. Okay, marks for this. There's 4 for the tree diagram. 1 mark for the 0.3. So for recognizing they need to add up to 1. A method mark for 0.7 times something is 0.28. Now if you've just written that down, you automatically get the 2 marks. So your answer mark is for 0.4. Then your 4th mark is for getting all the other branches filled in. And then for the final 2 marks, 1 mark for writing down the multiplication you're going to do and recognizing it's a multiplication, and 1 mark for the answer. So there you go, that is the intermediate tier paper 3B, so the even numbered questions. As I've repeatedly said throughout that paper, there's plenty of similar questions, not identical but similar questions on the Jones and Son website. So if you need to practice more of those, then please do so. If you want more, then leave me a message on the wall and I'll see what I can get organised.